Hi guys, welcome to lesson 9. So we are going to be talking in this lesson about patterns. And it may have been a while since you've talked about patterns and you may be thinking to yourself, oh, that's kindergarten stuff. Well, you're right. It is something that you learn or did learn way back in the day when you guys were preschoolers and kindergartners, of just being able to identify what would come next. But we also use it all the time. So we've been using it when we have been doing multiplication. So skip counting is a way of recognizing patterns, and multiplication itself is even a way of recognizing a pattern. We're going to start off by talking about number patterns. So I'm going to be starting off on page 176 for this lesson if you want to go ahead and follow along. Our question says, Orlando swims laps in a pool every day. This week he swims 4 more laps each day than the day before. He swims 20 laps on Monday. Find how many laps Orlando swims each weekday this week. So it does say weekday, so that tells us that we're going to only be counting Monday, Tuesday, Wednesday, Thursday, and Friday. So he doesn't swim on the weekends. So we're going to be doing 5 days, and they have in your packet a handy little table, and sometimes tables can be a great way to organize information. So here's Monday, here's Tuesday, here's Wednesday, here's Thursday, and here's Friday. And on Monday, we know that the number of laps that Orlando swam was 20 laps. We also know that each day we're going to be adding on 4 laps because it says this week he swims 4 more laps each day, 4 more. So more being that key word there, telling us that Tuesday he's going to be adding on 4 more laps than he did Monday. Then for Wednesday, adding on 4 more, adding 4 more for Thursday, and adding 4 more to that for Friday. So each time our number is increasing by 4, right? So looking pretty similar to what we've been doing with multiplication in the past before, or any kind of number pattern. So a number pattern is a pattern that you can find with working with numbers that follows kind of like a rule. And so the rule here is that we're adding 4 each time, right? So if we were to go ahead and fill in our chart, we would find that 20 plus 4 more laps. He swam 24 laps on Tuesday. 24 plus 4 more would be 28 laps on Wednesday. 28 plus 4 more would be 32 laps on Thursday. And then 4 more to that, he swam 36 laps on Friday. Now you may also be noticing that we're also talking about multiples, the product of times 4, right? So each time we're adding 4, we start off with the product of 5 times 4, right? 5 times 4 is 20. And then if we look at each of the next days, that would be like saying we have 6 times 4, 7 times 4, 8 times 4, 9 times 4 to get the product that would be here. Now, that isn't necessarily important information, except that it's just kind of fun to notice. But it's not necessarily going to help us find the answer to the problem, because it's not telling us that we're multiplying by 4 each time, but it is telling us that we're adding 4 each time. Just kind of a fun relationship to notice, that relationship between multiplication and addition. They also have, for the second, below the picture it, model it using a number line. So we can think of Orlando's number of laps as also being on a number line. We would start at 20, and then we would add 21, 22, 23, 24. He's adding 4 to get to 24, 25, 26, 27, 28. Adding 4 more again, 29, 30, 31, 32. Adding 4 more again, 33, 34, 35, 36. One more hop is adding 4. And then if we count them up, we see that we have 1, 2, 3, 4. Oh wait, I'm sorry. We have 4 hops, but we have Monday, Tuesday, Wednesday, Thursday, Friday, 5 days down below. Okay. So let's go ahead and answer some of the questions on page 177. So turning just to the next page. So number 1 says, how many laps does Orlando swim each day? And you can go ahead and fill in from the chart. On Monday, he swims 20 laps. Tuesday, 24. Wednesday, 28. Thursday, 32. And Friday, 36. Number 2 says, what is the rule you follow to get from one number to the next in the pattern? So remember, when we're talking about patterns, we're talking about a rule. And when we're talking about number patterns, usually that rule is going to be add, subtract, multiply, divide by a certain number. So in this case, our rule was each time we added 4, right? So 20 plus 4, 24. 24 plus 4, 28. 28 plus 4, 32. 32 plus 4, 36. Okay. Number 3 says, what does the pattern show you about what happens when you start with an even number and add to an even number? So this is what we're talking about, what I was talking about earlier, with how you can see patterns within patterns. So even if we're like skip counting, you might start to develop a pattern. So this question is saying, what does the pattern, meaning add 4, show you what happens when you start with an even number and add an even number? So 20 is an even number, right? We added 4. 4 is an even number. Our sum, our outcome, was also even. 24 is another even number. Let's see if that pattern still holds. So we add another even number, 24 plus 4. 28 is also even. So we have another even number. 28 plus 4 more, 32 is even. 32 plus 4, 36 is also even. So each time, all of the numbers in the pattern will be even. So that's kind of like when we skip count by 2s or when we skip count by 4s. We only talk about the even numbers, right? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I could keep going. I'm going to stop myself, even though it's so much fun to skip count by 2s. Because all the way through, it's just going to be hitting the even numbers because each time we're adding 2 more. This gets helpful when you're starting to think about factor pairs, because you can start seeing that certain numbers, if they end in certain number, they're always going to have certain multiples, but not, or I'm sorry, they're always going to have certain factors, but not other factors. So for example, if you have a number that ends in an even number, remember we talked about this in our practice page session, it's always going to have a multiple of 2. The one exception is 2, because 2 only has itself and 1 as its 2 factors. But all the other even numbers will always have 2 as well, because 4 is like 2 doubled. 6 is like 3 doubled. 8 is like 4 doubled. 10 is like 5 doubled, and so on and so forth. So all even numbers can be divided in half or would have a factor of 2. So it's helpful to start looking at some of these patterns, because that can help you figure out some of the problems as we get into more and more complicated math. So even though this seems really basic, it's still a good skill to brush up on. So we're going to go ahead and skip on over to page 178. And I've heard that pausing the video is not working to work through the problem. So I'm just going to go ahead and work through the problems together with you. So for number 7, it says, the first time Lori plays a new game, she scores 100 points. Each of the next 3 times she plays the game, she doubles her previous score. What are Lori's scores for the first 4 times she plays the game? Show your work. So you could show your work in various ways. You could show it with an equation. You could show it with a number line. I'm going to show it with a table, because when I'm working with number patterns, I really like tables as a way to organize my information. So I'm going to go ahead and make a table by first drawing out a rectangle. And then when I'm also going to label my table because that way I know which side the information is telling, what information is being displayed on each side. So I'm going to go ahead and start with a box at the top. And on one side, I'm going to say that that's the game number. And then on the other side, I'm going to say that that's going to be the score. So for example, for game number 1, it said that she scored 100 points. Okay, so that would be our first box, right? So I have game number 1, score would be 100. So this is how I'm organizing my information. Now, it says that each time she plays a game, she doubles her score. We know that doubling is another way of saying we multiply by 2, right? So I'm going to start with 100. I'm going to multiply by 2. So for game number 2, she scored 200 points. Now for game number 3, we're going to double 200 because it says that she doubles her previous score. So I looked at 100, I doubled 100 to get 200. Now I'm looking at 200, I'm going to double that because our rule is each time we're going to multiply by 2. 200 doubled would be 400. So the points that she scored for game number 3 would be 400 points. And now it says, what are Lori's scores for the first 4 times she played? So I have game 1, game 2, game 3. And so now we're going to look at game 4. We still have the same rule, which is that we're going to multiply by 2, the previous score. So I'm going to look at 400. 400 doubled would be 800. So Lori's first 4 scores on her game, if she doubled her score each time she played, would be 100, 200, 400, and 800. So where it says solution, you could write 100 points, 200 points, 400 points, and 800 points. Or you could go ahead and display it in the table like I did. All right, number 8 says, what is another pattern in Lori's score? So we could look for, within our answers, some other patterns that we could see. So I'm just going to name a few of what we see. Well, each number ends with 2 zeros, right? Telling us that we're working with hundreds. So we have 100, 200, 400, 800. So that's something that's consistent with all of the answers. We could also say that each one would be a multiple of 100, right? Because we're multiplying 1 by 100, 2 by 100, 4 by 100, 8 times 100. But that's still not going to get us our specific numbers. I could also say that I'm noticing a pattern in the hundreds place that each time it's doubled, right? And that is consistent with our pattern. So I have 100 doubled would be 200. 200 doubled would be 400. 400 doubled would be 800. So isolating out the digits in a number can also show you some of the patterns. A further example of that, this doesn't relate to this particular problem, but if I write out the numbers of 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So in this pattern, I'm counting by 2s, right? So again, if I'm looking at isolated digits, I could say that the ones place has a repeating pattern of 2, 4, 6, 8, 0. 2, 4, 6, 8, 0. So I know that my next number is going to be ending with a 2 in the ones place because that's consistent with the pattern. Okay? So I think patterns are really fun. In fact, I think that's one of the funnest things about math is looking for just those kind of patterns. It's kind of like opening up your eyes to a different way of seeing things. All right, so let's look at number 9. Number 9 says start with the number 16. Okay, I'm going to write number 16 up on the board because that's where we're starting with. Use the rule divide by 2 and write the next 3 numbers in the pattern. Show your work. Okay, so 16 is the number that we're going to start with. We're going to do 3 times of dividing by 2. So let's go ahead and say we have 16 divided by 2 would be 8. So that would be 1 time. Then we're going to take our 8 divide it by 2 again, equals 4. That's 2 times. I'm going to take my 4, divide it by 2 to get 2. That's 3 times. So my numbers would be, if I start with 16, I would list them out as 16, 8, 4, and 2 would be the numbers that I would get for that pattern. Now, sometimes you'll be given a pattern that looks like this and you'll have to find the rule. Other times you'll be given a number and asked to find the answers by doing the rule. So the next 2 pages, 179 and 180, we'll be covering in our practice session on Wednesday, rather. We are going to actually skip all the way to page 184 now. Which now we're going to start looking, we have been looking at number patterns. Now we're going to look at some shape patterns. And again, I know that pausing your video may not be an option. So we're just going to go ahead and start on page 184 and answer the questions together. So number 7 says the pattern below follows the rule, add a row of 2 circles each time. Describe how the total number of circles in each figure of the pattern is related to the number of the figure. Okay, that's a lot to unpack. So let's just start by looking at the figure. So they have 2 circles, and this is figure 1. And I'm going to abbreviate figure to fig. Figure 1. The next one, I have 2 circles stacked on top of those 2 circles. So that's figure 2. The next one, I have 2 more circles stacked on that one. That's figure 3. And then the next one, I have 2 more circles stacked on top of that. Okay, so now the first one says, describe how the pattern below shows the rule, add a row of 2 circles each time. So let's just go ahead and double check that. So we have a row, right? 1 row of 2 circles. Here we've added a row on top of it. Here we've added a row on top of those 2. And here we've added a row on top of those 3. So each time we're adding 2 circles on top of the other circles. So that pattern checks out. Now the second part of this question says, describe how the total number of circles, so here we have 2, here we have 1, 2, 3, 4 total circles, here we have 1, 2, 3, 4, 5, 6 total circles, and here we have 1, 2, 3, 4, 5, 6, 7, 8 total circles, how that relates to the number of the figure. So here we have 2 total circles at figure 1. Here we have 4 total circles at figure 2, 6 at figure 3, and 8 at figure 4. Now, if you notice that each of those is like saying you're multiplying the number of the figure times 2, you're noticing a pattern of how we would get our answer, right? So figure 1, if we multiplied it by the 2 circles, we get an answer of 2. Figure 2, if we multiplied it by the 2 circles, we get an answer of 4. Figure 3, if we multiply it by 2 circles, we get an answer of 6. And figure 4, if we multiply by 2, we get an answer of 8. So we could say that our rule is multiplying by 2 each time. So the total number of circles in each figure would be twice as much as the figure number, right? So we have figure 1 multiplied by 2 would equal the number of circles. All right, number 8 says, draw a shape pattern that goes back and forth between a 5-sided shape and a 6-sided shape, then describe the shape pattern in another way. Okay, so they're telling us that our rule is going to be 5-sided shape and 6-sided shape alternating. So we could draw something that looks like this. There's a 5-sided shape, right? We know that that's called a pentagon. I like to think of it as, it also, you can think of a 5-sided shape as looking like a house. And a house that we live in the woods is called a tent. A pentagon, tentagon, kind of the same thing. I know it's kind of a stretch, but that's how I remember it. So pentagon or five-sided shape. And then we have a hexagon, which is a six-sided shape. So we could draw alternating five-sided shapes and six-sided shapes. Actually gave us hard shapes to draw for this problem. Okay, so here I have a pattern of five-sided shape, six-sided shape, five-sided shape, six-sided shape, five-sided shape, six-sided shape. I'm alternating the 5 and the 6 sides each time. So now the second part of the question says, describe the shape pattern in another way. So we could call them by their names and say that we are alternating, alternating pentagon and nope, not octagons, hexagons, six-sided shape. So that could be another way that we describe our pattern. Let's look at some of the things too. I noticed that the pentagons have a pointy top and the hexagons have a flat top. So we could also say that we're alternating shapes with a pointy top and with a flat top. That doesn't give us quite as much detail because it doesn't tell us what specific shape. And so we could have something like triangles and squares alternating as well, right? That would also fit that pattern, but it is still a way that we could describe our shape pattern. Pointy top, not pointy top, pointy top, not pointy top, pointy top, not pointy top. Okay, so there's lots of different ways that we can describe patterns, and the more specific we get, the more we'll know how to continue the pattern. All right, number 9 says the shapes in Sarah's pattern go back and forth between having an even number of sides and an odd number of sides. Which pattern is Sarah's pattern? So we have 4 options. Let's see which one works. So even number of sides alternating with an odd number of sides. So A has a square. That fits with having an even side. And then it has a diamond. Diamond has 4 sides, therefore it's an even number of sides, so A will not work. Okay, let's look at B. B has triangle, even number of sides. I think it says that we're alternating an even number, I'm sorry, triangle has an odd number of sides, and I think it says that we're alternating even number of sides with odd number of sides. So if that's true, this pattern wouldn't work, but maybe we're starting in the middle. So let's just check the next number or the next shape just to be safe. Just to be safe. There we go. Can't talk. All right, so now we have triangle, pentagon. Pentagon has 5 sides, so that would be like odd, odd. So that's not going to work either. So B also does not work. And it wasn't just because we started with an odd. It was the fact that the pattern goes odd, even, odd, even, or even, odd, even, odd, alternating. We have odd, odd. So that's not going to work. Okay, C, we start with a circle. Wrong right away. And the reason why is because circles do not have any sides, right? Or you could make the argument that they have an infinite number of sides. However, circle does not fit the category of either odd or even number of sides. Therefore, we know that it can't be C right away. So the only option it can be is D, but let's double check to make sure that it actually still fits the pattern. So we start off with a 6-sided shape, a hexagon. That looks promising. Then we have a triangle, odd number of sides. Okay, so far so good. So we have even, odd. Let's make sure though that it's continuing to alternate between even and odd, because if I had triangle next, then it still wouldn't fit the pattern and none of these options would be right. And then our book would be trying to trick us. But as it turns out, the next shape is indeed a hexagon that has 6 sides. So far we are alternating even, odd, even, odd. So D would be the correct answer. All right, pages 185 and 186 we will also be covering in our small group on Wednesday. Pages 187 through 190 you're welcome to do for some extra practice. But that wraps up this lesson. I hope you guys had as much fun working with number and shape patterns as I did. And I'll catch you on Wednesday. Well, actually, I'll see you before then. But see you Wednesday for math. Okay, bye.